So the next speaker for this session is going to be Dr. John Walsh. He's the chief scientist of the International Arctic Research Center, and he's going to talk to us on sea ice variations in the Northern Alaska Navigation Corridor. John.
Thanks, Pablo. I'd like to thank you and John for inviting us here. It's always nice to come to DC for this meeting to see what's happening in the real world. So we'd like to touch on some issues that we think may have some relevance for actual operations, what happens in the Alaska Navigation Corridor. And we're coming at this topic from the perspective of indicators. There will be a couple other, well, there was one talk yesterday by Walt Meyer on indicators. Harry Stern's giving another one this afternoon. So this is I think a topic that's emerging in the sort of the climate and even in the operations community. I'd like to acknowledge the co-presenters here, Florence Federer, who's in the audience, and Scott Stewart, both from NSIDC. This is the outline. We're going to present a Beaufort Sea Ice Severity Index. We're going to look at its variations and trends over the last 60 years. Then we'll look at its representativeness and its seasonal predictability. And we'll come up with a reconstruction that goes back to 1850 for this particular index. Then we'll have a brief extension at the end to the potential for Pan-Arctic indicator development as it relates to some regional indicators. So just by way of background, we're going to start with a severity index that's been around for a long time for the Beaufort Sea. This is the Barnett Severity Index. This index has its origins back in the 1970s, back when there were sea lifts in connection with the Alaska oil pipeline construction. Most of the infrastructure up at Prudhoe had to be barged in. And that was for the construction of the pipeline that spans the state. The pipeline is the red line on that upper right map. And in the midst of the construction, the summer of 1975, there was a major disruption of the barge lift because of the sea lift, because of sea ice conditions. And this few sentences in the upper part of that diagram summarize the challenge. Crowley Maritime was operating the barges, most of the barges back in those days, and this is from their publication, 50 Years of Service in Alaska. And they point out here that as they were trying to get the sea lift to Prudhoe, going around Barrow, they were held up by the ice for 2 months. And there was only a very narrow window when they were able to squeeze through, get the supplies and the equipment to Barrow, and then barely get back out again. It was just a matter of days. So it was almost a major maritime disaster in the sense that they were almost forced to overwinter in the ice. And this was back in 1975. By contrast, we had last summer's cruise of the Crystal Serenity. We've heard about that in several talks. The main question there was the passage through the Canadian archipelago. There was no issue when it came to getting through the Alaskan waters, the Chukchi and the Beaufort Sea. So this Barnett Severity Index is intended to capture the changes in the navigability of this northern Alaskan corridor from year to year. And this index is based on a number of different metrics, 5 of them. It's actually the sum of the 5. And these are somewhat apples and oranges in the sense that some of the metrics are distances to the ice edge, others are lengths of the open water period over various routes, and they're simply added up into an index that measures the severity of the ice conditions in the navigation corridor between Barrow and Prudhoe. And this is a plot of the index. The red lines show the index. Because it's a sum of the 5 metrics, it's not a normal distribution at all. It really amplifies the changes in ice conditions. But you can see how there has been a regime shift, low values through the 60s, 70s, 80s, into the 90s, and then very high values in the last decade. But because this metric compounds the changes in sea ice, we wanted to go back and sort of capture the changes in a more linear way. So we're going to be coming up with a metric for the Beaufort Sea, which distinguishes essentially the open water period for navigation over years such as these, 1980 and 2015, which are contrasting years. And we're then going to extend this index to different regions. This is a diagram from a paper by Claire Parkinson a couple years ago, showing the observed changes in the number of open water days around the Arctic. We'll be focusing on the Beaufort and Chukchi Sea, which is one of the areas with the largest changes. The numbers there are in the, say, the 10 to 20 day per decade range. There are other large changes over on the North Atlantic side, somewhat smaller changes in the Russian seas. You'll also notice that the largest changes in the Alaskan sector have been offshore, not right along the coast. So the index we're going to be using is essentially one component of the old Barnett Severity Index. It's number 4 on the list. Number 4 on that list of the Barnett Index is the number of days the sea route from Barrow to Prudhoe is less than or equal to 50% concentration in a calendar year. It's essentially saying that there needs to be a continuous corridor of open water defined by that 50% concentration threshold. This index was actually put together at the National Ice Center by the analysts. It was used in a paper that came out last year by Goldstein et al. In the cryosphere. And it is, again, basically one component of the old Barnett Index. It's an open water metric, but it is tied to navigability in the sense that that requirement for a continuous corridor needs to be met. Got locked up here. There's a panel that this thing popped up. How do I get rid of that?
Just click anywhere in the
Oh, okay, thanks. So here's what that index looks like. This Beaufort Severity Index, as we're calling it, which is again, one component of the Barnett Index. The red dots in that diagram are the severity index, number of days in which the corridor is navigable. We've also plotted on that diagram the ice extent in the Beaufort Sea. That's the blue curve, and the blue dots are the August extents. And you can see how this severity index is really a somewhat muted signal of the change, at least relative to the actual ice extent and relative to that old Barnett Index. And that sort of muted character arises because of the requirement for the continuous corridor. If there's even one cell in the corridor, or one small area in the corridor that's blocking the the open water connection, that day is not counted. So what we're looking at here is a sort of a more modest metric of the change. Here is a comparison. This repeats the plot earlier, but it's a comparison of this severity index that we've defined it, the gray bars at the bottom, relative to that old Barnett Index. And you can see how the Barnett Index is much more, again, it's amplifying the changes much more than this severity index that we're using. The black arrow down there at on the bottom refers to 1975. That year we looked at the barge lift summary from earlier. That was the year when both indices came in with a 0, in the sense that there technically was not a single navigable day for the entire corridor in that year. You can contrast that with the typical values of 80 to 100 days in the last decade by our index. By the old Barnett Severity Index, you're up in the many hundreds of the mixed units. So what we'd like to do now is see how this severity index for the Beaufort relates to other regions and whether there's any inherent predictability in it just based on the simple extents. To do that, we've used the National Ice Center and NSIDC regions. They're shaded in with different colors in this figure. There are about a dozen of them. We're essentially going to be comparing this severity index with the measures of ice in those other sectors. When we do that, we just perform some simple correlations between that Beaufort Severity Index and the regional ice extent in other sectors. The comparison with the Beaufort Sea extent is the upper left diagram, and we've taken the correlation of this index with the other indices back into, with the other regions, back into earlier months of the other region's ice extent. So in the case of the Beaufort, the correlation there peaks. Those are actually R-squared values. 0.3 R-squared corresponds to a correlation of 0.5 to 0.6. But you will notice that based on that September, let's see if I have a pointer here. The September value is only about 0.3, which is saying that this severity index only correlates at about 0.6 or so with the actual ice extent in the Beaufort Sea. Correlates significantly with the extents a few months earlier, but not much farther back. Correlates well with ice extent in the Chukchi and the East Siberian Sea, but the time scale for those correlations is only a couple of months. There's essentially no correlation between this Beaufort index and what's happening on the Atlantic side. Next point is the reconstruction. This is the attempt to reconstruct that severity index back to 1850. For this, we use the database that we talked about at the last conference here 2 years ago. This is a database on Arctic sea ice extent extending back to 1850. That database is available through NSIDC. This is a summary of the primary data sources. There is a mixed bag of data sources. They range from the whaling records in the 1800s through a number of chart series, ice chart series, and other data sources in the 1900s to the passive microwave in the most recent decade. And here's a summary of the ice variability through that record as a function of time on the x-axis, that's year on the x-axis, and calendar month on the y-axis. So you can really see the recent drop-off in the summer season. It's fairly striking. Just in the last couple decades, there's actually an increase in the summer season. Back in the early part of the 20th century, and even in the 50s and 60s, there's been a weaker decrease in recent years in the summer season. And here's one last figure just showing the general character of the variations in that data set. These are the years of the minimum ice cover, September ice cover minima, the extremes of different 50-year periods, as well as the most recent 13 years. These are the years are marked in white. 2012 stands out. That's the year we've heard is the record minimum. But there was nothing like that in the previous 50-year periods. Nothing like that back to 1850. So what we've done here in reconstructing that Beaufort Severity Index is to regress the Beaufort Severity Index on the regional ice covers with which the correlations are significant over the past 50 years. So we've essentially used this period here from 1953 onward as a training period and reconstructed the Beaufort Severity Index through that regression approach. Now the colored bars here show the errors in that reconstruction for the past 50 years, for our training period. In the red bars show where the reconstruction underestimated the actual index. The actual index in the red cases is the top of the bars. In the blue cases, it's the bottom of the bars, down to 0 in 1975. So this reconstruction tends to damp the variance, doesn't catch the extremes. So we do need to realize that there are probably some extremes missed in the earlier period. But the main point here is that even with this muted index of change that we've worked with in the Beaufort Sea, there's nothing like the past decade in the earlier historical record. So the period does stand out from a navigation-oriented index as being unique in the historical record. And the last item I'll touch on here is the extension. This is an initial attempt to extend this indicator development to the Pan-Arctic scale. What we've done here is taken the Pan-Arctic ice extent and correlated it with the regional ice extent. We've also correlated it with that particular Beaufort Severity Index, and this is the one figure on the results in this category. We're correlating the September Pan-Arctic extent with the earlier ice extents in different regions, different sectors. And you can see here that the correlations with the northern regions tail off to zero, mainly because there's no variability in the winter months to correlate with. But what is coming out here is some statistically significant correlations with even the previous winter and spring's ice extent in the Barents Sea, and to a lesser extent the eastern Canadian region, the Baffin Bay, Gulf of St. Lawrence region, which is saying that there does seem to be some carryover between the variability in earlier seasons in regions that have an ice edge bounded by the ocean, and what we're seeing in the Pan-Arctic sense in September. So here's our summary. We've constructed this Beaufort Sea Index, and well, we didn't construct it, we've used it. But what we found is that it is an indicator of summer ice severity, not just in the Beaufort Sea, but also in the Chukchi and the eastern Russian subarctic seas. But that indicator role only plays out in the summer. It doesn't extend back any farther than that. So in that sense, the simple correlative predictability, the predictability by these correlation approaches, is limited to 1 to 3 months and to information from the Pacific side of the Arctic. The third point is that this present period of diminished ice, especially as it relates to the navigability in the Beaufort region, is unique in the historical record back to 1850. And the last point is that there do seem to be some leading indicators, just in this simple correlative approach. There seem to be some leading indicators in the form of the ice extent in earlier seasons in the Atlantic sector, and those are leading indicators for the Pan-Arctic September extent. And what we need to do there is extend that to other seasons after determining just how much of a role the trend effect is playing in that initial finding. So that's the last slide, and thanks for listening.
Thank you, John. John, I have a question online. Are there existing data sets back into the 1800s in Russia that would assist your effort to reconstruct a Pan-Arctic reconstruction, or to construct a Pan-Arctic reconstruction?
I'm not aware of Russian data sets, but there was a database put together during ACCESS, Arctic Climate System Experiment. That was one of the CLIC predecessors. And that's based largely on Norwegian information. Roger Colony had a lot to do with that database, and that actually goes back into the 1700s. Those are essentially depictions of the North Atlantic ice edge. Where we'd come up short in a Pan-Arctic reconstruction is on the Pacific side, and as far as I know, in the eastern part of the Russian subarctic.
Thanks. Any questions from the audience? First one, Ali.
Thank you. So are you, or how are you integrating this kind of predictive capability with the shipping industry and the insurance industry, the kind of way to use this sort of information going forward for safety and security, for emergency response? You know, are you able to apply this in a seasonal way that can help the users of the area?
Well, that's the object, to come up with some seasonal scale predictions. This is we're following one approach here, which is basically using the antecedent ice cover to uncover some lines of predictability over that seasonal time scale, and the indications are there may well be some in connection with the Atlantic. Now, there are other approaches that can be used. The Sea Ice Prediction Network has a lot of different inputs. They come from numerical modeling groups, heuristic approaches, and other statistical approaches, including some analog approaches. In fact, Mark Serez here has a nice example of how the Bering inflow is a good predictor of ice extent in the Chukchi Sea over these time scales. So I think we're all targeting what you were referring to from different approaches, and there are signs that there is some predictability there. The challenge we really have is optimizing it at this point. But I think we are at the point where some useful information can be provided to these user groups.
Once again, thank you, John, for your contribution.